Everyone, welcome to a new session on machine learning. So today we are going to see about linear algebra. As I have said in the introduction session, we have two more main important topics which we have to discuss before learning machine learning algorithms. One is statistics and another one is linear algebra. I guess I have given enough number of topics in the statistics. Now let us get into linear algebra. This linear algebra series is very much similar to the Gilbert-Strang video, which you can see in MIT courseware and YouTube channel, or you can refer his book by Gilbert-Strang Linear Algebra, uh, or else you can watch this video. For some people feel that Gilbert-Strang video is very much difficult to understand. For those people, I have made that videos in a very simplified form in this series. So you can check out either those video or book or this video. So that is up to you. But at the end of the day, you have to learn what is meant by linear algebra. So in this video today, we are going to see about matrix form, row picture, column picture. So row picture, column picture, and all used for finding the unknowns. Okay. So matrix form. So what is meant by matrix form? So let us see that. So Ax equal to B. I guess you have heard much about this when you have encountered linear algebra topic. Then you have listened what is the mean by Ax equal to B. So if you have given n equation and n unknowns to find, then you can write those equation in the mathematical form using vectors and matrices using Ax is equal to B. A is a matrix of coefficients of unknowns and X is the unknowns, that is X, Y, Z, or how much number of unknowns you have given in the equation. Then B is the right hand side. Okay. If you multiply A matrix and X vector, you will get the right hand side. That is, here for example, you can see this mathematical form like 1x. This row can be, first row can be multiplied with the vector, whole vector x, y, z. So you'll get 1x plus 4y plus z equal to 4. That is what the first equation here. If you take the second row and multiply with the x vector, capital X vector, then 6x 4y minus z equal to 5. The same way you can take vector and last row vector in the matrix A, 7 minus 5 0, and multiply with the vector capital X, X, Y, Z, you will get the value 6, that is in the B. Okay, so this is the mathematical form, and another form for representation of X unknowns and X equation, that is given equation in the mathematical form. Okay, so now let us jump into the row picture and column picture. So what does mean by row picture? You will get to know what does mean by row picture if you learn these topics. I mean these slides. If you listen these slides very carefully. Okay. So 5x minus 6y is equal to 9. 7x plus 10y is equal to 16. This is the two equation. That is two equation and two unknowns. Okay. So unknowns here is x and y. So let me write. So we don't want to jump into linear algebra as such. Okay. So let us go in the way what you know already. Okay. In your schools you have read how to draw a graph using x and y axis, right? You'll be given the equation, one single equation like this, x 6 5x minus 6y is equal to 9, for example. If they have given the equation, then you will convert either into x or y. So now universally everyone will convert those equation into y, that is keeping the 6y this side and making the other terms to right hand side. You can do this. Okay, so y is equal to 5x minus 9. Now for x you can assume the value like minus 1, minus 2, minus 3, 0, 1, 2, 3. For example, these 7 values you can assume and substitute those x values in this equation, that is in this equation, and you can find the y value. So this x and y, if you plot in the x and y axis graph, that gives you the solution for this equation. Okay, so let us find this using this Excel sheet. Okay, so we're going to the Excel sheet first. So this is the graph for the two equation. So if you see here, this is the solution for the first equation, that is 5x minus 6y and equal to 9. This is the solution for the first equation. So do is you can wait a minute. Let me copy and paste here. So if you see here, I have given the x value, which is x value from 1 to 9 and minus 1 to minus 9. I have applied in this equation. See here, I have applied in this y is equal to minus 5, that is 5x minus 9 by 6 in this equation, and I have found the solution. See here, I have written this equation and the solution, and I have dragged to the rest of the values. Okay, so those two things I have plotted in this graph, this x and y axis graph. So this gives me a straight line which passes to the almost origin, but not in the origin. So the points lie on this line as a solution for this equation. So if you take any value, that is 3, 1, and substitute in this. So see here, x value is 3 and y value is 1. So what is the value here? 5 into 3, 5 3 is 15, minus 6, minus 6, okay? 15 minus 6 gives you 15 and minus 6 gives you 9. So if you take any value in the series and if you substitute here, then it will gives you the 9 value exactly. Okay, so now let us see the second equation. 7x plus 10y is equal to 16. So this is the second equation. So same way I have converted the second equation into the function of y. That is y is equal to function of x, that is y is equal to function of x, where y is equal to minus 7x plus 16 by 10. From this equation I have simplified. Okay, so now the solution for this equation is, so here the solution for the equation. What I have done is, similarly I have placed the x value from 1 to 9 and my minus 1 to 9. Wait a minute, let me paste here. So see here, if you see x value from 1 to 9 and minus 1 to 9. See, I have substituted the values of x in the y equation and I have found these values. If you substitute any of this value in this equation, you will get the answer as 16. These two things are plotted in this graph to give this to make the straight line. Okay, the points which lie on this equation gives you the solution for this equation. Okay, now this is the two equation and two unknowns. We have find the solution. So that is what I have given here. This is the solution for 7x plus 10y is equal to 16. And this is the solution for 5x minus 6y is equal to 9. And this is the row picture intersection. That is two solution I have plotted in the same graph, and those solution intersect at a point where x is equal to 2 and y is equal to 0.166, or for one equation, and for another equation x is equal to 0, x is equal to 2 and 0.2. So it is almost 0.2, or you can have a 0.166. If you replace x and y in this equation, okay, in this equation, or in this equation, if you replace x is equal to 2 or x is equal to 2 here, and y is equal to either 0.166 or 0.2, almost you'll get the answer as 9 and 16. So here we have found the solution for two equation, two common solution for this two equation using the row picture. Okay, so row picture is this form. Using the graph we have found the line, using the equation we have found the line, and using the intersection we have found the solution. Okay, so what if we have three unknowns and three equations? Okay, so three unknowns and three equations, you can little bit you can imagine like three dimensions like x, y, and z. So here I have written the three unknowns in the three equation in the ax is equal to b form, where 4 minus 1 5 minus 3 2 minus 6 5 3 4. It is in the matrix capital A, and capital X vector has x, y, z, that is the unknowns, and the right hand side has the 10 minus 1 and 4. So this is the equation. Now it is very easy for us to find the solution for two equation and two unknowns. Now for three equation and three unknowns, what we have to do? So very easy. With those vectors, okay, like row vector, each row vector, I have plotted them in the three-dimensional plot. See here, this is 4x minus y plus 5z is equal to 10. Approximately this equation forms this plane. Okay, so in this three-dimensional axis, this equation forms a plane. Okay, then next one. Next equation is minus 3x plus 2y minus 6z equal to minus 1. That equation forms this plane. So I guess you can see here this plane. Okay, this plane intersects the previous plane which we have drawn before for this equation. So two plane intersection forms the line. Okay, okay. So let us see that if it is a two, that if there is a two plane, see if this is one plane and this is one plane, if the two plane intersects, then the common intersection points gives you the line. Okay, now the third equation, that is 5x plus 3y plus 4z equal to 4. Now this is the third equation. That third equation forms this plane, that is this plane. I'm just moving the mouse over that plane. I guess can you can all see that plane. So this is the third plane. If the third plane is intersect the previous two planes, then there comes the point. So that is the common solution for this three equation. Okay. If it is an equation for lion, then it forms a two unknown equation. Two unknown equation. If it is a lion, then that is a solution. Okay. So first a plane, the two plane intersects and forms a line, and three plane intersects and forms a point. Okay. So now let us see what is the column picture. So column picture, 5x minus xy is equal to 9, 7x plus 10y is equal to 16. The equation which we have taken for the row picture. Okay. Now I have written the column picture here. This is x, 5 and 7. So if you see here, 5 and 7 here, this is x plus y is equal to minus 6. Okay, here minus 6 and 10, which is equal to 9 and 16. Instead of writing in the row form, I have written in the column form. Okay, so now instead of writing x and y, we know the solution already, that is x is equal to 2 and y is equal to 0.166 or 0.2. You can substitute those x and y value here, that is 2 and 0.166 here. If you substitute if you substitute here, that is 5 2s are 10 plus 0.166 into 6, which gives you 9, and similarly 7 2s are 14 plus 0.166 into 10, which gives you 16. So this is very easy. Since we know already in the row picture, we already know the solution and we have substituted, and the column picture is very easy. Now I guess everyone out there can visualize what is meant by column picture. Okay. Now if we move for higher dimension where few things are very difficult to visualize, then what we'll do? So there comes the solution. So if in column picture, when a matrix is, if it is a three dimension, then you have to consider this. When a matrix is non-singular and invertible, then we can solve for Ax is equal to B that lies in any of the given plane. Okay, either in the 3D plane, it lies in any of the three planes. Okay, if a matrix is singular and non-invertible, then we cannot solve for Ax is equal to B because B lying out of the plane, sometimes it is unreachable. So what is meant by non-singular and invertible? So here, singular and inverse matrix. If a matrix is a singular, then determinant of that particular matrix should be equal to 0. If it is not, then non-singular matrix. So what is meant by inverse of matrix? If a matrix is given A, then you have to find its inverse. So if inverse can be found using 1 by determinant of A into adjoint of A. Okay, this gives you inverse of the matrix. Then if you multiply the matrix and matrix inverse, it should give the identity matrix. Okay, identity matrix. If that is, then it is an invertible matrix. So our condition is, if we have to solve for the Ax is equal to B, then it should be non-singular and invertible. Okay, so here it should be non-singular. Determinant should not be equal to 0, and here identity matrix should be, we should get, that is A into A minus A inverse. So So in the 3D matrix, which we have discussed before, that is 4x minus y plus 5z is equal to 10, minus 3x plus 2y minus 6z is equal to minus 1, 5x plus 3y plus 4z is equal to 4. That is the equation which we have seen here, okay? Which we have seen here. So this I have written in the ax plus b is equal, ax plus b form. Now let us see what is the determinant of this matrix capital A. So this determinant gives you 27. If you want detailed explanation for singular matrix and also for invertible matrix, please do let me know in the comment section. So I'll take a separate video on that. Okay. Now this matrix equation gives the determinant value as 27 and the inverse matrix value is 0.96, which is almost equal to 1, and 0.7 minus 0.14, so which is 0 0, and you can have minus 0 here. It is minus 0.7, I guess, so it is minus 0.7, and here minus 0.6, minus 0.3 and 0.3, and 0 minus 0.7, 0.6 and 0.18. So sorry, this is the inverse of the matrix. Sorry, this is inverse of that particular matrix. Okay. So which we have found using this formula, that is A inverse is equal to 1 by A, 1 by determinant of A into adjoint of A. Okay. So this gives you the inverse matrix as this. If you multiply this matrix and this capital A matrix, this capital A matrix, that gives you the value of, that gives the identity matrix. So identity matrix value is almost equal to identity, that is 1 1 on the diagonals. So here the value is 0 0.96, 0 0.7 and 0. For this inverse, it is the identity matrix, the value is almost equal to 1 on the diagonal. So you will get 0 0.96, 0 0.98, 0 0.99 on the diagonals, and for the rest of the value it might be minus 0 0.7 or 0 0.4 or 0 0.12 or something. So you will get almost a similar identity matrix. So for our equation, that is 3 equation and 3 unknowns which we have given here, this is non-singular and also it is invertible. So if it is non-singular and invertible, our solution, we can find the solution for Ax is equal to b. So these Ax is equal to b, we can solve it, and the solution may lie in any of the given plane. Okay, if it is a singular matrix and non-invertible, then we cannot solve for Ax is equal to b. So that is what in a nutshell. So I guess you have cleared about row picture, column picture, and what is meant by matrix form in this video. In the next video, I'll take a detailed class for what is meant by column picture, and we can also use MATLAB for at times for solving this column picture. And also I have to mention one thing here. If you don't want to involve in so much tedious calculation for finding determinant or inverse matrix, then you can very well use any of the application in your mobile phones or using MATLAB. Okay, if you want to use MATLAB, then give inverse of A, that gives you the inverse matrix of the particular matrix. Okay, inverse of A or inverse of B. If you give determinant det of particular matrix, then it gives you determinant value. It is very well easy to solve for these values in the MATLAB, and you can also solve it in online calculators in the web or using the application, mobile application in your mobile phones. There are some Android apps which supports vector calculations. You can download it and very well use it, but I usually suggest for MATLAB or sometimes online calculator if necessary, because you can do these calculation for 2 dimension or 3 dimension. When it goes for higher dimension, it is very much difficult for you to calculate these values. So I will suggest you to download MATLAB, a trial version, or you can purchase MATLAB student version, so that it is very well useful for you in this series. Okay. Anyways, we are going to learn machine learning algorithms initially in the MATLAB, because it is very easy to learn machine learning algorithms in MATLAB than in Python or R. So I feel this way. So whatever your opinion, you can go with that. For my video session, I would recommend you to install MATLAB in your laptops or in your desktops. So very well, you can get a free version, trial version for 1 month in MATLAB website. So that is up to you for getting or using trial versions. Okay. So that's all for the today's video. Let me give you a short glimpse at what we have learned today. We have learned about matrix form, row picture and column picture. In row picture is very much easier to find, and when it goes for higher dimension, it is very much easy to difficult. We can visualize till 3 dimension, but you cannot pretend to visualize for higher dimension. That is what Gilbert Strang in his video will mention, like he cannot even visualize what 9 dimension thing will do. Okay, so this is the case for the row picture. It is very much difficult to find answers for a higher dimension. For that particular case, we are going for the column picture. So this is the column picture, and this is the condition for column picture for finding the answers. So detail about column picture we'll do it in the next video. So till then, take care. Bye bye.